How's it going, everybody? In this video we're going to take a look at wrapping up the initial setup. So that means that we've already gotten everything deployed. I'm going to go ahead and come in here and do a quick ping test just to verify everything's working. If we come in and do -2, we should be able to ping 61. If we come in here and we do a 65-1, we should be able to ping it. And then 65-2, we should be able to ping him. And then we'll come in here and do a 67-1. And then we'll be able to do a 67-2. Okay, so that proves to us that from this node's perspective, he has connectivity to everything, which is a really good sign. Now what we're going to go do is focus on the networking componentry. Understand what it is, how the network works inside a workstation. So essentially, really all it is you're creating a virtual switch inside of VMware Workstation that you'll be able to take and associate NICs on individual virtual machines to that particular VM net or VM network. That's really all you're doing. And what that's going to allow you to do is separate different types of traffic. For example, you can have on the inside of a host or whatever the case might be, you can separate storage from data, from vMotion, from whatever you want really. So it gives you the ability of providing a level of segregation between the networks that you're going to be working with. So in order to actually make this work the way that we want it to, we're going to click on the Edit and then Virtual Network Editor tab. That's going to launch this guy right here. And right now, I've already created a bunch of VM nets. So to create one, if we were just to get rid of this guy and say Remove Network, and then we were to say Add a Network, we would say VMnet 7. We can choose whatever we want. We got a whole bunch of ones available. We're just going to grab the first available. Click on OK. It's going to automatically assign an IP subnet to that. So if you want to affect how that happens, you go to DHCP settings and you can determine what the subnet is that is determined or what is associated via the IP addressing. I really don't care at this point on what these are. The only one I really care about here is VMnet 1. VMnet 1 is going to be a network that we take a look at in terms of the operations. So that's going to be data. That's going to be the first one we take a look at. So VMnet 1 is going to be a data net, is a data VLAN or a data VM net. That's going to allow the VMs that we deploy on the individual ESXi hosts to be able to communicate with each other between the ESXi hosts, but not outside of the host. So when I say host only, that means that these ESXi servers that we've got configured right here, they will have VMs running inside of them. So if you were to think about it like this, let me go ahead and pull out my pen tool real quick and kind of give you guys a high level overview of what I'm referring to. If we look at it from this perspective, where we take an ESXi host, right? We're going to have multiple connections coming off of the ESXi host, and we're going to grab 2 of them just to demonstrate what this is going to look like, right? So we run multiple connections off the host. What we're going to do from a VM net perspective, we're going to VMnet 1, then 2, then 3, and then 4, etc. Right now, VMnet 0 happens to be bridged. That means that communication from the outside is being allowed to pass through the NIC, this guy right here, through the physical host and into VMware Workstation. And so what's happening is, if we were to draw a line across here, the very first NIC on each one of these hosts is attached to VMnet 0, which is bridged. This is how we're able to associate a 10.255.1.x IP address to here. So for example, we've got .60 and we've got VM.61. That's how that's happening. So think of the bridged here. We're basically creating a switch port on the NIC that's physically connected to the rest of the physical network via VMnet 0. That's why it says bridged inside of the VMnet configuration. The rest of these guys here are also virtual switches. Think of each one of these guys as a VLAN. Right? We don't actually have the ability of tagging or doing any external trunking connectivity out to the physical infrastructure, but we can make virtual switches inside of VMware Workstation. So each one of these is its own individual VLAN, so on and so forth. What that gives me the ability of doing is I can start to separate the traffic. So I can draw another line here, another line here, another line here, another line here. So then I can start dragging connections from here down. Let's redraw that line real quick to this, and then this one can come all the way down to here, and so will this guy, and then this line will come all the way down to here, and this line will come all the way down to here, so on and so forth. The benefit to this is you can have each one of these connections as a different role or usage. So this one right here would be for management. This one right here could be for data. This one could be for storage. This one also could be for storage. This one could be for vMotion. Just for some, for examples, in that particular case. So these are for instances. Now, the cool thing about that is when you go through and you do this, you're providing segmentation at the VM level. So then you would, on here, on your ESXi host, you would create a bunch of port groups. You would create additional vSwitches, and you would associate them to a VM NIC. And the way that this works at a high level is if you have a ESXi host and you have a couple of NICs physically plugged into the host, like so. What you can do is you can create, so this right here is called a VM NIC. So it's a physical adapter. This is what allows the communication to a physical switch to happen. So I'll draw a physical switch, and then you run connections to this physical switch. This is how this happens. Now, what's going to end up happening is on a per NIC basis, what you're going to do is you're going to create a vSwitch. This is what they refer to as a virtual, virtual standard switch. No different than this guy here, but just in software. And then you map on a per vSwitch basis. This VM NIC gets mapped to this vSwitch. Okay, this vSwitch here has the ability of creating two different things. You have the VM port group, and you have the VM kernel adapter. Okay, think of this guy as a VLAN. Think of this guy as a switch virtual interface, because that's literally what it's doing. This right here, this is where VM vNICs get mapped to. Okay, so when you go to create a virtual machine, so we create a VM, right? And this VM has a NIC attached to it. You place the NIC in the port group that's associated to this vSwitch. And what that allows you to do is it allows you to provide separation. So, for example, a virtual machine that is going to be used to provide some sort of service in your network, it is going to be, its network adapter is going to be placed inside of a port group. The port group is a VLAN, because when you create the port group on the vSwitch here, so we create a port group here, the port group has the ability of having a VLAN ID associated to it. So let's say, for instance, you have, let me move this over here a little bit. You have a VLAN ID that's associated to the port group. Now we can come over here and create another vSwitch and create another port group here. This port group could be another VLAN, and then you can create another port group over here. For every port group that you create in a vSwitch, or regardless if you have one vSwitch or if you have 1,000 vSwitches, and you create a port group is going to be a VLAN. You associate a VLAN ID. That's basically how we're going to be doing it here. The SPI portion of this here with the VM kernel adapter, this is where you're going to do things like iSCSI. You could do fault tolerance logging, etc. There's a bunch of other things that you can do when it comes to iSCSI or the VM kernel adapter. Oftentimes what will end up happening is I will create a VM kernel adapter on a particular vSwitch for testing purposes, so that I can be on a physical switch, I can log into it, I can do a ping to the VM kernel adapter IP address, and that's going to allow me to validate that the connectivity from the physical switch down to the ESXi host is good to go. So this is probably the most complicated portion of virtual networking. You have to be able to understand the correlation between the virtual and the physical. Now, one other thing that I want to talk about is this is if you have multiple physical links, right? And all the ports on this side here are access, and so on and so forth. So you, on this side here, you would have whatever VLANs you need to create. So you would create VLANs, 10, 20, 30, 40, etc. on here, and then you would do whatever trunking you need to do to the rest of the physical infrastructure. Now, there's another variation of this, which we are not going to be demoing, at least not in this series of videos, and that is going to be where you have a physical switch, or physical host I should say, where you only have one or maybe only two NICs or VM NICs associated to it, and then you have a physical switch northbound, right? So you have your physical switch here, and it's got a couple connections on it, and then you run these connections down to here. But what you do on this side here is you take these two ports right here and you put them into what they call a port channel or a link aggregation group, or whatever the case might be, whatever you want to refer to it as. When you do that and you come down over to the host side and you do the same thing, you create a single vSwitch. This vSwitch is then going to have both VM NICs associated to it in a active role. And what you're going to do is on here is you're going to create multiple port groups. And I'm just going to draw it down here. So let me adjust that real quick. Let me draw this the entire here. And I'm drawing this intentionally over the VM NICs over here just to help you understand the process. So you create a port group here, port group here, port group here, port group here, and a port group here. And let's say we've got 10, 20, 30, 40, 50. So each one of these port groups has a separate VLAN ID, and then you just create VLANs 10 through 10, 20, 30, 40, and 50, respectively. Now this connection right here becomes a trunk. Now on this side here, there is no specific configuration. You can just map an additional adapter to your an additional VM NIC to a vSwitch, and that's going to allow it to have physical NIC redundancy. And then the connection on whenever traffic goes through this port group, it's going to get tagged with whatever VLAN ID you give it. So if you have a VM sitting over here inside of the port group of 10, assuming that they've got like 10.1.10.21 and .22, for example, when that traffic comes out of the ESXi host, any traffic from that port group will be tagged with the VLAN ID of 10. Same thing with this one here. This one will get VLAN 20. And then you'll have, same thing with here, 30, 40, and 50, respectively. This gives you the ability of having trunking enabled, and then you can scale that physical connectivity out. And then you can go and create just a single vSwitch, like vSwitch 0 for example, and you can create multiple port groups inside of it. That gives you the ability of adding scale to your ESXi host in the event that you only have a couple of physical NICs to do stuff with. That's what allows the scalability to come into play. You separate on a per port group basis the VLAN at a VLAN basis on how you separate your traffic, and then as traffic comes in from the VM, it leaves out the VM or the VNIC of the VM, hits the port group receives the traffic in, sends it up northbound out the VM NIC, so the physical adapter, and as that's happening, it's going through the port group adds the VLAN ID tagging of 10 or whatever the VLAN ID is, so when the traffic goes out the VM NIC, it's then tagged with the appropriate VLAN information. The switch receives that and goes, oh, you're in VLAN 10, and it's off to the races wherever you've got to go. That's basically what's happening here. Not terribly complicated, but it's one of those things that if you don't understand how vSphere networking comes into play, this can be a difficult topic to really wrap your head around. So that's basically what we're going to be doing in, I'm going to clear the screen, I'm going to pause the video, power all the VMs down, all the ESXi hosts. I'm going to add one network adapter. That's all I'm going to do for right now. Add one network adapter, and then what we're going to do is we're going to tie that network adapter to VMnet 1. Once VMnet 1 comes online, what that's going to do, we're going to tie each ESXi host, the new network adapter, to that VMnet, so that whenever a VM inside of the ESXi host is associated to that VM network, they're going to be able to associate with that network and then send traffic between each other. So let me kind of give you guys a high level of what that's going to look like. So we have VMnet 1 right here, right? We're going to create a vSwitch in here called data on both sides. We do that, and what's going to end up happening is we create VMs on both of these servers, and their NICs are going to get placed into this port group. So when you click the drop down box in the VM creation, you're going to choose the data port group to put them in, and what that's going to allow them to do is whenever VM 1, 2, 3, or 4 want to talk to one another, they just have to send their traffic out. Let me switch the color real quick just so it's easier for you guys to see. They send their traffic out VM out here. That hits the port group, comes out here, rides across the virtual switch back up here until it drops off on VM 3, and then they're able to communicate with one another. The same holds true for this guy. So if switch VM2 wants to talk to VM4, he just does the same thing, right? He goes there. I mean, it's all inside of the same network. They're all able to communicate the way that they need to. They just need to go through the process of associating the right adapter and all that type of stuff. And in the next video, I'm actually going to show you how to do all that, because when you start diving into those details, you really need to understand the major operations that's going on. It's really, really critical that you understand that. The other one that's literally right above my head at the moment, I'm going to be demoing that in a different set of videos where I will go through and show you how to do this. What I'm planning on doing is running some ESXi hosts inside of Eve, and I will be connecting them to Nexus 9Ks. I'm going to do some testing on this to see if it'll actually work, because I would like to test things like NSX and some other stuff out. But for right now, this is where we are currently. So with that being said, this is where I want to get in, play around with the technology and see how it all works and stuff like that. So that is basically where we are at. Until next time, guys, thanks so much for stopping by and hanging out with me, and we'll catch you guys in the next video.